Last call for refactoring, risky code coming in. Track 2. Hello everybody. Welcome to my talk about refactoring risky code. My name is Phillip Hofman. I work for a company called My Sugar. We are based in the beautiful capital of Austria, in Vienna. It's a very, very nice city, so if you're there, it's not just famous for Mozart, we also have a few other pretty places there. Who actually already watched my first talk, so maybe quite a few, the others don't know me, so it's good that I just tell it twice. My Sugar is a company, we make diabetes suck less, so if you don't know us, that's actually good, because if you did, that would mean that maybe you have diabetes, or somebody that you know has diabetes and it really sucks, and our mission is to make it suck less. But anyway, we're here to talk about refactoring risky code, and because I got that question already a few times, no, that's not me in the picture, that's just some guy doing some crazy exercise on a flat line. Before we start into thinking about how we can refactor risky code, so what is risky code? Actually, by the way, that's a really crazy guy in Yosemite climbing a very high wall without a rope, so it's a very nice movie also, you could check it out. So risky code, it is a code that has low test coverage, or even almost no tests. It has a high test effort, so this means whenever you change something, you have the QA is really pissed by you because he needs to test it with loads of different devices, and it could actually break a lot. And that is also what's called side effects. So if you change it, it's like if the product owner comes to you and asks you, can you maybe change this? And everybody's like, oh, no, I don't want to change this because I'm scared, I'm afraid of that. That's for me risky code. Some people also say legacy code, but legacy code is for me kind of more just old code. So usually code that you just get, that you have to deal with, but legacy code can also be actually pretty nice to work with. Sometimes it's just hidden behind a nice interface, it does what it does, you don't know what it's doing, but it can still be okay. Risky code is different. And at the end of this talk, I hope that you will also have the confidence of not being afraid to touch risky code. That you say like, okay, I want to refactor it, I want to change it without being afraid of doing that. And this talk originates from an experience report dealing with Bluetooth. And who of you has already worked with Bluetooth on Android? Oh, wow, quite a few people. So it can be really risky, right? So you finish something and then somebody comes and complains, okay, now it's not working anymore with this device, it's not working with that device. And then you say like, yeah, but I could change this now, and maybe, but then I break it again for other devices. So how can we deal with this? The test automation is a pain for Bluetooth. So the QA, we have like, I don't know, at the end we had like 100 different devices to really make sure it was working. And then when there's just a new operating system version, again, some things are breaking, and it can be a really, really huge pain. I just said that. So, at my company, we had a stable Bluetooth stack. The problem with it was it had almost no tests. It was not testable, it could break a lot, and therefore make the users angry. So the good thing was actually it was working. It really did its job. But then, looking into the future, the management came to us and said like, okay, make it extendable and changeable. So what would you think, okay, if you have something that you cannot change and it's really difficult to change, you're not dare to touch it, you might as well like, okay, let's just throw it away, just drop it into the bin and rewrite it completely from scratch. Let's start from a really blank page and completely rewrite it. The thing that you forget if you do that is your code is already battle-proof. So it's out there, loads of users have tested it, you have loads of bug fixes in there, there's like months of QA power in that code, and if you rewrite that, you might throw all of that stuff away, which is not really wise. And luckily I read this article from Joel Spolsky. It was written in 2000, so this is already almost 20 years old, and it's called Things You Should Never Do Part 1, and I can really recommend reading that one. And he exactly explained that. So if you throw away all your code, that's not maybe the best idea. So instead of that, of rewriting, actually we want to refactor. So now let's take a look at what refactoring is, because I know that some people sometimes say they're refactoring actually when they're rewriting. So let's go to the single source of truth, Wikipedia. So it says like code refactoring is the process of restructuring existing code without changing its external behavior. It continues, refactoring is intended to improve non-functional attributes of the software, and advantages include improved code reliability, reduced complexity, this can improve maintainability, and create a more expressive internal architecture or model to improve extensibility. Okay, there's lots of things in there. I just highlighted the bold that you don't have to think, and I just take out the key ones. So the first thing is really, really important is restructuring without changing its external behavior. So the users, when you're refactoring, actually shouldn't even know there's a difference. It looks the same from the external part. So that's one of the key things that I think you should remember. And you improve non-functional attributes like changeability, maintainability, extendability, and things like this, if you do it right, of course. Another nice thing is you do the improved code readability and reduce complexity. So this is something I usually say, like when you do the Boy Scout rule, so always leave the campground cleaner than you found it. It's also kind of something of refactoring. So if you just come to a method and say, okay, this is really complex to read, and you just modify it a little bit, that it's easy to understand, you're actually refactoring it and improving the non-functional attributes of the code. And by making it more readable and stuff like this, you actually, I think you also improve the maintainability. So, I mean, for us, it's sometimes hard to argue to management or product owners, why should we even refactor? And like I said before, any fool can write code that a computer can understand. So I didn't say that before, but making code easy to read really makes sense. So any fool, if you maybe remember when you started coding at the university or somewhere else when you were a kid, or some people, I don't know when you start, you just write some code, it works, and then you take a look at it a day after that, or maybe a week after that, and it's like, I have no idea what this code is doing. So you don't really understand it, you really have to go dig into it to understand it again, because the variable naming is really not that good, so it's like really short characters and letters. And then once you just pick up clean code and think about, okay, really giving proper names to the variables really makes sense. And that's actually what good programmers can do. They write code that humans can understand, because the computer doesn't matter if you do clean architecture, clean code, or whatever. The computer just executes what you give him. And I think this mastering the skill that if you have code that somebody else can understand, and the future you can also understand, is really, really hard to achieve. And it's really a skill that can take years. Martin Fowler said that actually. So why to spend time improving the readability of the code and make it easier to read? So we spend loads of time reading code, like 70 to 80% of our time we actually try to understand code. Code that somebody else wrote, code that you wrote, and thinking about this, it's like completely crazy, I think. So just always sitting there and writing your code, it's not much what time you spend. Also, if you're just coding something new, what you usually do is you read your code over and over again to know like what are the next steps I want to take. I just want to give you an example. Take a look at this code, and as soon as you know what it does, please raise your hand. Actually, it doesn't really matter because it's really complicated. Maybe if I name it properly, count occurrences and give them a little bit better names, maybe it's easier for you to understand. But actually, if you maybe do it like this, raise your hand as soon as you know when you know what it's doing. Good. Like after a few seconds, right? So don't feel bad if you don't get it, but it's just a purpose. Like the beginning, nobody knew, but I think this, if you spend now 30 more seconds and think about it and know Kotlin, then you maybe understand that stuff. And I have to admit, I'm not a genius. I'm like a normal, average, intelligent person, so I cannot work with this crazy code. I need simple code, because otherwise, I don't know how to change it, I don't know how to deal with that. But still, when you go through your code base, usually sometimes you come into a room that looks like this and think like, okay, what is this? Is this still used? What does it do? So you find dirty code everywhere sometimes, and I guess we also have those, like you spend a whole week of investigating a bug and suddenly you find, okay, now I know how to fix it, and you just fix one line, and then the QA is actually testing it and saying, like, it looks good, then release it to the users, and then, okay, it looks good. But after 2 weeks, users complain and say like, oh, okay, actually you broke it on 2 other devices, especially in Bluetooth, or like on 20 other devices. You have to go back again, and then you take a look again. You lost all of it that you like, it's 2 weeks past, so you again have to read into it, and the same process over and over again. And this can be really annoying, and this happens all the time. But so when you then see something code like this, and you go to management and say like, can I have a little bit of time to improve that stuff? You usually go like with the mindset, okay, now we know better. This time we're going to do it right. This time it's going to be perfect. It's going to be easy to read. Everybody can actually extend that stuff, and it's reusable, and this has a high test coverage. And you're really like, yeah, let's do it like this. And then you start, and at the end, bam, you end up again with a huge mess. And maybe, I don't know, it takes longer than expected. You expected it. And then also you get some pressure because you actually want to get it out of the door. And at the end, it's going to be a mess again. But that's totally normal. Even the best get it wrong sometimes. So even the best engineers, when they code, usually when you code something, the best ones create less. The ones that don't really know what they're doing, they really create a huge mess. But it's totally normal, and we have to communicate this to management. As we're coding, we try to improve the mess, but at the end it's going to be a little bit of mess again. And if we don't communicate this to management, I think we lose trust. The good thing is, when you code, it's like a metaphor, it's like you're cooking. So you're in the kitchen, you make all the dishes dirty, but you have to do them immediately afterwards, because when you did the dishes, when you cooked, and you do the dishes immediately afterwards, it's easy to clean. If you let them stay around for, I don't know, 2 weeks, it's really hard to clean. So when you're writing new stuff, when you're improving existing stuff, usually when you're done with that, you have way more knowledge how to make it better, because now you really know how to solve the problem. And what you should do then is actually you should take this, I don't know, extra sprint or extra day or a few days into actually improving that, because you still have all that knowledge in your head, and not just put it away and go to the next thing. Okay, now we know what refactoring is, why it makes sense. It really helps to improve the non-functional attributes of the code, to make it easier to read and to understand. But when we do that, how do we do that actually without breaking it? And the simple answer is tests. Actually, not just tests, but loads of tests, many tests. So it's really safe to refactor when you have good test coverage. And I would say, from that perspective, code without tests is a bad situation, because you cannot touch it, you cannot improve it. It doesn't even matter how pretty or abstract it is. So even if it was testable code, even if you are doing clean architecture, where you have all the abstractions everywhere, it doesn't really matter, because you cannot change it. I just have to say, code without tests can also be a good situation. So if you're building a prototype, you're building something that you know that you're going to throw away, or maybe you're just trying a few things out, it's also okay that you don't have any tests. But as soon as you know it's going to change, and that's almost ever the case. So I don't know, I cannot even I can even think of something which I hadn't to change afterwards. So even it looks perfect in the beginning, the product owner is coming to you and tell you, hey, come on, change it again. So change is really certain. If you have testable code, it's really the next step. So code with tests is easy to change. If you have well-abstracted code, you can just add the tests and then refactor. But actually, we want to talk about the Bluetooth stack. How can we refactor that? So it had almost no tests. It was not testable. It could break a lot and could make the users angry. So how to refactor the risky code? So no tests, neither is it testable. And if you do one false move, it makes boom, you blow up everything. So how do we do that? It's actually not so complicated. You take the risky code, you make it testable, you add the tests, and then refactor. Right, yeah, but the tricky part is in here, right? So how do we do that? I call this deep coding, so put on your headphones, really get some focus area, long uninterrupted work, and you should really know what you're doing. And doing that, you basically get rid of non-testable dependencies while you add abstractions. I'm just going to give you a simple example. We have some use case, whatever I call it, greeting. I have the context in there, the connectivity manager, and basically we just return a greeting based if you're online or offline. And testing this, I mean, the context, actually I can mark that stuff, it's not so complicated, but the connectivity manager might be a little bit trickier. So let's say, okay, we want to get rid of this. We can just throw it into a class. You don't need to create an interface for this, because with Mockito you can also mock final classes. If you, it just modifies the bytecode for you, so you can do that. Some people also like to create interfaces for this, but if you always only have one implementation, I think it's kind of an interface overuse. And if you can mock it, I just care about testability, just write it into a class and then you can test it. And then we're just going to use it inside my greeting. And I already get rid of one dependency. Some people also don't like to have the context in there because maybe we want to have a plain Kotlin module, so we also get rid of the context. In this case, I do an interface, just do the Android implementation in the Android greeting resources, and then we're going to reuse it. Now the class is pretty small, and I can test like completely crazy. I mean, there's not much to test, but it's easy to test it. And that's what we also did with our Bluetooth stuff. So we had our Bluetooth stack in our app, and what we did is we call it now Blue Candy, that's our kind of Bluetooth framework, and we just ripped it out of the app and split it up into two modules. And the upper module is the core module, which is plain Kotlin, plain Java. It has no Android dependencies, and down there's the Android code. Just a simple example, because I'm not going into details about Bluetooth, because that's a nightmare and I don't want to frighten you. So that's like something for scanning for devices. We used coroutines there, and then on the Android side, we just implemented stuff. All the other stuff is pretty much, so yeah, it doesn't fit into one slide. So actually it's just, the core stuff contains the logic, and the random part is stupid. Then you can really go crazy and test nuts. Just have to sip of water. Okay, so now we know how to take risky code. We're going to make it testable. We're going to add a few tests, add a few tests, and then refactor. But actually, going through the process, you need kind of a survival guide, because otherwise you will die or you'll be kicked out of the company. And it's just a long list of tips. I'm just going to show you what you can do when you do this. The first one is refactoring. What else? Just keep in mind, previously I said, when we refactor, we don't change the behavior of the code. We just improve the structure. So don't mix it up with, I don't know, you see that and it's like, okay, on Bluetooth especially, you just want to add the abstraction, and if you would also say, okay, this doesn't really make sense, maybe I change it a little bit, that can really mess up your code. So you should really first add the abstraction, refactoring and improving the structure, then add a few tests, and then afterwards you can go nuts without knowing, without breaking anything. And then sometimes I have people telling me, I know what I'm doing, okay, I can handle this, but trust me, you don't. So usually you end up breaking things, and really stick to this rule. There's also a metaphor from Martin Fowler. He calls this the refactoring hat metaphor. So he says, like, either you're refactoring, either you're adding functionality, you're changing things, and you should mix the two. And I think it really helped us when we were refactoring our Bluetooth stack. The next one is keep your code green. So there's a nice URL diagram in here. It's really easy. So hit compile. If the compilation fails, fix the error or revert your changes. And if it succeeds, you can make a small change. And that's what helped us really when we were taking all this stuff out of our app and trying to adding all the abstractions. So, because if you say, okay, now my build is not working anymore, you have an error, and you're building faulty stuff on other stuff. So your basement is on fire, and if you build a roof on top of it, at the end, your roof is also going to be on fire. So it's really, really important to always be in a clear state when you refactor and always have it working. Let's just give me an example. So we have two packages, or two Gradle modules, called one the Miller, the other one the Jacksons. We have two classes in there. Justin depends on Chris. We have Frank and Tina as well, then they're not feeling lonely. And if I want to move Justin to the Jacksons, it doesn't work because those two don't have any dependency. And sometimes when people try to move classes from one spot in the project to another one, Android Studio then tells you, hey, there's an error, and they just ignore it. And then you actually break the code, which is not a very good idea. Instead, what you should do is try to do it in a way that you don't get any errors. So you basically just grab both of them and move them over, and maybe check that Chris doesn't have any, Frank doesn't have a dependency on Chris. In this case, it's fine. Or you just add the dependency and then move Justin, and then of course you could also move Chris and then get rid of the dependency in the end. So it's always good to keep your code clean. Next thing is small tasks. So, I don't know, you refactor class, and you say like, okay, I want to change it, and then, I don't know, you go nuts and say, I want to change this, I want to change that, and at the end you end up with a huge mess. I've already seen this multiple times. Really don't go crazy, really stay disciplined, so clearly define a goal, what you want to improve, create a small ticket, and just, okay, I just want to extract this class. And if you just go completely nuts, then there's so huge testing impact that basically your stuff will never get merged, and then your PO gets angry and you get angry because all the work you did doesn't end up to the customer. So really do small tasks, merge often, and avoid those huge pull requests. That also can help you. Because if your project gets dumped at, I don't know, in between, you still got a few small things that improved your code. So if you have a branch that just lives on for months and then you want to just merge the big bang, that's going to be huge. Basically then it can be a disaster. Yeah, just don't do it. Commit a lot. So when I reach a clear state, I say, okay, now I move that stuff, I immediately do a commit. Because this allows me to always go back in time. So if I have a clean refactoring, I do the next one, it's always a little bit tricky, and I mess it up, I just revert it and try again. And another nice thing that you have from this is, when I was refactoring the Bluetooth stack with my colleagues, I basically get 10 to 20 commits, and then I just did a smoke test if the Bluetooth is still working. So if it was not working, I just went back like 10 commits in time and see, hey, is it still working? If yes, then maybe, I don't know, I search and go back in time, go back and forth with the commits and to find out which change actually broke the code. Can also help you. And even if all those tiny steps you're doing, like commit after commit after commit, you can still make big achievements and refactor like the whole code base. The next thing is use the tools. So we're happy on Android. We have Android Studio. Don't do stuff manually. So Android Studio is your friend. You can do so many things with it, like moving it around, renaming, pulling members up, pushing members down. It's really, really awesome. So, and I never had a case where I just moved something from A to B that it actually broke the build or something. So the refactoring tools from the JetBrains people are really, really awesome. Compared to Xcode on iOS, so who did already refactor on iOS? Maybe, I think it's a really pain, right? So you have renaming, right? Or sometimes?
Rename doesn't work. Even rename. If you rename like it renames the production code, but doesn't rename the tests.
Okay. Oh yeah, that's or like moving. I don't know if you can move classes around. It's like really like, oh my god, yeah. Android Studio, just do it. You don't care. That's really nice. But that's why I love Android Studio. Find and replace can also help you. I know maybe the iOS guys are better with this. If you have like some complex things you want to change, this can also help you. The next thing is keep your tests green. So again, an ICML diagram. So run the tests. If they fail, fix them, and otherwise you can make a small change and run them again. If some of your colleagues is telling you, I'm refactoring and my tests are broken since 2 days, they're not refactoring. They're just going nuts. Again, like with the compiling stuff, if you have tests failing, it tells you something in your code is broken. And again, you cannot build things on a faulty basement. So you always need to make sure that all your tests are green. And if they fail, immediately go back and try to fix them. Maybe the test is also lying. So really don't continue with failing tests. The next one is tests. So really have as many tests as possible. What I also get sometimes from other developers is like, okay, I built now something, and why do I need to add tests? It works. It's like this, okay, now maybe a single movement, but it will break down. So what am I testing then? When you have it already that's working, and the future usually doesn't look bright. So it's really a little bit dusty. It's a crazy ride usually. You have waves, and change is going to come. And tests, if you have tests, even for something that is working, allows you to change your code. Let me give you an example. So we have an enum. On an expert level, we have junior, senior, and ancient, because I think like everybody with 3 years of experience is already a senior, which doesn't really make sense. So what do we call the really experienced people? So I call them ancient. And we just want to calculate a bonus. So basically how long they were in the company, you enter this and you enter their salary and you enter their level, and then you just get the bonus. So the junior gets not so much, the ancient gets more. I use the float. I know for currencies that's not really accurate, but just for simplicity I leave it out. So we have 4 tests. Testing it, so we have few salaries, which basically prove that our code is working. And then a week later the management comes to you and says like, okay, but actually the juniors, they should have to be here for 2 years that they actually receive a bonus. So what do you do then? Okay, we just change the tests that are highlighted there, and if you do TDD, you just run them and see, okay, one is not working, you go to your code, you modify it to make it pass. Maybe that's not the best modification, but it works. You just run the tests, all of them are green. If you're smart, you maybe think like, okay, maybe I should also add a few tests for the senior and the ancient guy, that they actually, also the edge cases are covered, so you actually then have 6 tests. You run them again, and basically it's working. But then after some time, management comes again and tells you, hey, come on, this isn't really fair. The junior has 2 years and the senior has just 1 year. Let's maybe modify this and say, okay, he should be here 1.5 years. And you just modify the tests there. Then you run them and you see like, okay, one is failing. And then you have this code, and now the tests give you coverage to completely mess it up and completely change it. And you can do it like this. You just say, okay, now it should be 16, and then you run the test, and everything is fine. Okay, but now, there was a mistake in it. Did anybody see something that was not accurate? Tests are green, right? So code is working. Be aware. I said like 15 here, but I forgot to change here to 15. It still says 11. And if you now change this to 15 and run the tests again, one is failing. And actually we see what the problem is. We forgot to add here the equals or bigger equals to. So we modify this, and then it tests are green. So I just wanted to let you know, just because your tests are green doesn't also say that your code is actually working. So make sure that your tests are actually testing something. One last thing that you can do is mutation testing. Does anybody know what mutation testing is? Ah, really? Nobody? Cool. Ah, you know it. Great. So mutation testing is basically just modifying your code, modifying your bytecode, and to basically change conditions or just remove lines of code and see if a test is failing. And if none test is failing, it means basically you left one line of your code without proving that it's working, something like this. Also code coverage helps. Just aside and Google it, mutation testing. It's a little bit tricky to set up on Android, but if you have really some critical software you want to write, it can help you. The next thing is minimize the damage. So even if you, especially when you're in the phase where you have the risky coding part, you still got a really of a bad stomach, and you say like, okay, maybe if you didn't release it, it could be there are some problems. So the simplest thing that you can do is you can do a stage rollout. So on the Google Play console, you basically can just say, when I release this, I just release it to, I don't know, 1% of my user base. If it's then going to be a disaster, those users are going to scream and tell you, and then at least the other 99% won't have the trouble. The bad thing is, of course, those people, you cannot take the version back from them, so you need to do a hotfix. But it's better to have like a hotfix afterwards, and the other 99% of the users need to wait actually for the hotfix, not for the newest version. So that's something, that's a very, very easy thing how you can do to minimize the damage. Another thing is, if you have alpha user base, use alpha testing, really makes sense. Also, what you could do is you could put your refactoring behind a feature switch. So you could actually have like one feature twice, and then also could do a staged rollout. And if it really messes up, you just roll it back. It really gives you safety. And you can roll back within a minute. What we also did, especially with Bluetooth, is we duplicated our code. So we had a few classes and a few implementations which were critical. We just added some interfaces and had different versions of them, and just had feature switches telling like which version it should use. And we also then included a secret status view for the QA. It's still there, so if you tap on in our app on a side menu, a specific parent or the logo, you see the status view telling you which version of the Bluetooth code we're actually using, because otherwise they were always going nuts and like, okay, is it now working with this version, and is this a bug or not? And then they really know which version they're testing and really have good confidence. Next thing is ship. I already mentioned it before. I think it only always counts when it's shipped. When you refactor something, you should also make sure that you get the power from QA or from management, the resources, that it actually gets to the customer. So we once had somebody upgrading RX Java, like in the whole code base, but basically there wasn't a QA able to test it. And he spent, I don't know, a week updating it, and it would have taken a QA, I don't know, 2 or 3 weeks to completely test the whole app because it has dependencies everywhere. And then basically at the end we ditched it because we didn't have any QA power and we had always merge conflicts, and it was really, really, really frustrating. So keep always shipping in mind whatever you do. So now, what I want you to remember is refactoring is not rewriting. So refactoring is improving the structure of the code without changing external behavior. And this can also lead to improving non-functional requirements like extendability, changeability, maintainability. That's really important. So rewriting is throwing it away. Then once again, the refactoring survival guide. So just do refactoring, not adding functions. Don't switch skip those two, mix those two. What you can do is, of course, if you do the Boy Scout rule and add a new feature, you can do a refactoring and do a commit and do another one, and then you add functionality. You can mix those two, but if you do a bigger one, like really you want to add a few abstractions, mixing them really ends up in being really, really bad. Keep a code screen, so it should always compile. If it's not compiling anymore, go back. Keep your test screen, same with tests. Have loads of tests. Try to do small tasks, because if your project gets killed, you still got a few small things that get actually shipped to the customer. Commit a lot, because then you can easily go back and identify the exact change that actually caused the problem. Use the tools, don't do it manually. Minimize the damage with feature rollouts and ship. Yeah, so last thing, refactoring risky code is really just, you have to take the risky code and make it testable. You do this with deep coding, so really know what you're doing. And then you add the tests, and then refactor, and then we're done. Thank you. I think I can take questions, right? It's the time.
Questions? You need to raise your hand, so I know. So, if you're moving from Java to Kotlin, so do you recommend refactoring the Java first and converting it to Kotlin, or do you recommend doing it at Kotlin instantly, or not doing it at all?
I definitely would recommend refactoring to Kotlin, but I think it depends. It's a stupid answer, but I guess.
Sorry. So my question was whether to refactor Java, make it like clean, and then convert it to Kotlin, or whether to do it at the same time, clean the code and write it in Kotlin at the same time.
I mean, if it's easy, you have this converting Java to Kotlin. I think it's easy. I would immediately convert it, because usually with Kotlin, you have way nicer features. It's easy to read. It makes less boilerplate, and also in Kotlin you can do usually nicer things than you can do in Java. So if you refactor your code in Java and it looks really nice, and then you turn it to Kotlin, and then you might have to refactor it again, because in Kotlin there are other things possible which you don't have in Java. So I would actually say convert to Kotlin and then refactor.
So particularly with Bluetooth, how do you really balance the line of stuff you want to test and stuff you want to make sure you're not mocking something that you don't want to mock?
So what we did is, our purpose was we wanted to create a framework that is aligned with the BLE standard that's publicly posted, and you could just implement your BLE, GUT services, and whatever. And all of that stuff that you need, we said like, okay, this should be plain Java and plain Kotlin. And all the logic that you actually need for achieving this, so really also like just queuing the message in the right way, passing the data especially, I think where this kind of all Bluetooth logic is in, this should be kind of, I think can be plain Kotlin, plain Java. And all the things that's really tricky to Android, so you say, okay, I want to disconnect the GUT, and especially on this Android version, I need to retry it 3 times or whatever. I think this can be kind of closer to Android because this logic wouldn't make sense to actually put it into BLE because it's Android specific. So actually redrawing the line is really, really hard, but like the Android stuff into the Android modules and putting it, you can also have plain Kotlin code in there that you really, really test. But all the other logic like parsing the data, reconnecting, writing to the data and things like this, and the whole threading thing, which was really complicated. This we did in plain Kotlin and Java. If this answers the question, we can have a chat afterwards, we can go into more detail because it's not so easy to explain the whole concept there.
Hi, I'm just curious about your experience. How do you give visibility to the amount of work that you put on Refactor? And when it stops, like you add a job to refactor a full module, or you just doing because you need it to do, because it will be a mess in the future. So how you give visibility with the management for the needs of Refactor, and should it stop or not?
Yeah, so that's always it's a very good question because we always like sometimes we just like to do say, okay, I need to refactor this because it's not good. But actually what really helps is to write down why is it not good. And what helped us was, okay, we knew that new devices were coming, and it was always a huge pain that when adding a new device, the side effects were so huge that you also had to retest all the other devices. And if you actually can prove this and kind of say, okay, the current quality is like this, if you think about a few things that will come into the future, and it slows us down, and give us time to improve it, and you say, like, okay, give me, I don't know, 2 weeks, or maybe half a year. For us, it took us almost half a year to do it properly. And then you have to also prove that we actually achieved this. So what we did is actually we have glucometers that the users use for measuring the blood sugar. And we said, okay, we want to build it in a way that if you add a completely different Bluetooth service, that you don't have to retest all glucometers. And what we said, like we thought of a scenario and said, like, okay, if we added a heart rate monitor integrating via Bluetooth, how difficult is that for somebody who has not experience with Bluetooth? And do we also then don't have to retest the whole glucometer things? And we came up with a scenario like this where we could actually prove that we reached a point where we're satisfied with the quality. And the first time we tried it, we completely failed. So the guy trying it was like, oh, I have no idea how to do it. It was not really finished. And then we identified a few problems and iterated over it again. And then it kind of worked. And then we could actually see, tell the management, okay, now take a look. The guy didn't really have that much knowledge about Bluetooth. And now it takes him 2 days to integrate a heart rate monitor. And it works. And then how with this, if you go with this approach, you can actually prove that the new refactoring reaches a certain goal. The short answer is just, yeah, define like why it's a bad situation, and then define the desired outcome, and also think of a way to improve your outcome.
So, do you have any questions for the audience?
If I have questions,
so,
really.
No, we are out of time. Thank you so much. Hands of applause to Phillip. Thank you.
Thank you.